So basically, I'll start with some introduction about Solid State Circus Society, what we do for young professionals, and for this group. After that, Jan van der Spiegel is here with us. He'll give a welcome speech. And today we have two special guest speakers from here in Austin, from Silicon Labs. So Tyson and Daniel will share their own experiences shortly and tell us how they reach where they are. Afterwards, we have several more mentors among us, so I'll ask them to introduce themselves. And the main idea about mentors is mentors will tell you what they are doing, how they reach where they are, so that you can get to know them and you have the chance to talk to them one-on-one after the session starts. So this will be a very informal session so that everybody can be relaxed and talk to them. And these mentors are here, they are welcoming to share their experiences with you. So first of all, what is young professionals? Because this question comes often. Basically, we are engineers, graduate students, and faculty within 15 years of our undergrad degree. We know that we are passing through a transition. We finish school, we are starting our careers or the first years, and our needs are a bit different than experienced people like some of our mentors. And in addition, we are the future of Solid State Circus Society. In 10-15 years, we will be the leaders, hopefully, of the society to push our area even further. So this event is one of them, so that the experienced people, mentors, can share their experiences with you. And then we, Solid State Society, we have several other benefits that is mainly focusing for young people, and I'll mention some of them in the next slides. But some of the key points is, I would like to encourage you all to be YP leaders in your own local regions. So we have chapters programs that you can invite several distinguished lecturers and make events. So this is the time to get to know about those benefits, so you can go back and be leaders in your own area. And again, today it is a relaxed one-on-one question meetings after the introductions. And then in the tables you'll see some forms. All students can get 1 year complimentary membership if they are in this event. So just take that form, fill it in and send us, because we want you to experience the membership for a year. Then let us know how it is, what kind of benefits you would like to see from us. So hopefully you'll be part of our community for longer. And also there is information about several talks that will be in UT Austin later this week. So you are all welcome to join them, and this is one of the benefits of Solid State as well that we are offering. So this is some of the benefits that I think and we think are quite beneficial for young people. So we have the ISSC, as you know, there are several tutorials, short courses. Several people can make it there and many of them cannot. So you can go to our webpage and access several of the previous tutorials and short courses, and they are timeless information. They are very good. Even if they are 5 years ago, you can still, if you are doing a research on that area, they are very useful places to check. We have webinars where you can listen to one of our distinguished lecturers give a talk, and then there is a live Q&A session, so you can ask questions and that person can respond to your questions as well. In addition to that, we have several other webinars. They are recorded, similar to the tutorials, you can watch them. We have distinguished lecturers, several of them are also our mentors here with us. You can invite them to your own city to give speech to all your students, all your colleagues. We have student travel grants, predictoral achievement awards. Also, if we want to encourage more people to be active and to volunteer and to be leaders, so if you are very active, you can apply for this leadership volunteer travel grant to come to some of the conferences. And then this is a good way to establish a local chapter, so you can, basically the idea is to get the benefit out to more people, so our Solid State area gets bigger and stronger, that we can keep it up. And I think it's a very good way of developing leadership skills as well to volunteer. So this is our resource center. I'll just show that one. So here you can see several of the webinars, short courses. Also now we have that was ISSCX before. Now we have VLSIX, and in several conferences there are short talks about the area that you can listen and get familiar with. So these you can all access from our resource center. This is our browsing app. We all like the journal, but here you can access now with the new generation through your phone and tablets. And these are some examples of the webinars that has been held that you can still go to our webpage and watch. These are the short courses, tutorials that you can see. And these are some of our distinguished lectures for this year. And the roster get updated, so more and more distinguished lecturers come, and then you can always invite them. This is some of the examples of like where they go and talk. So you will see more of them coming up basically later this week, even in Austin. So this is a very, very short introduction about solid state. So if any questions, you can ask now, or you can always catch me after all the presentations from the mentors. And yeah, so welcome. And then I'll next introduce Jan Spiegel to give a welcome speech from solid state. Thank you.
Thank you, Emily, for a very nice introduction. I'm not going to give a speech, just say a few words of welcome. I'm glad to see that so many people are here, among students. I assume a lot of students here, and young professionals, as well as mentors. So I'd like to echo what Emery said about the importance of young professionals and students. You are the future of the society, and that's the reason that we as the society want to invest in you. We want to put a lot of resources in it, because your future and our future depends on it. And so you see a lot of these advantages that were mentioned. And if you have any other suggestions how we can help you, feel free to let us know. So we have the travel grants, we have the tutorials, which I think is very useful for students or even young professionals who get involved in a new area. You go to this resource website and it's for free as long as you are a member. Let me just poll you briefly. How many of you are students, actually still graduate students? If you can raise your hands. How many of you are considering yourself young professionals according to the definition by Emily? Okay. And are the rest all, maybe the mentors can also raise their hands? So I'd like to specially thank the mentors for coming and sharing your experiences with our students and young professionals. So from my point of view, I have been involved with the Solid State Circuit Society as an undergraduate student. And I must say, it was probably one of the best career decisions I have made. It really has impacted my career in a very positive way. It has opened so many doors, and it has been in contact with some of the best people in my field, which I never would often otherwise be able to do. I would never be here and stand in front of you if I wouldn't have decided to become a member and continue my membership. Sometimes it was hard to pay for it, but I stuck it out, and I think it really is paying off now. And I think the same can be true for you. I also like to mention and emphasize the very importance of being involved. Get involved at, let's say, the chapter level, or at the young professional. Contact Emery, maybe you want to help him out. We can use a lot of your talent. And it's a way for you to network, to get involved, and eventually to grow step by step. And maybe one day also stand here and talk to the young people of the next generation. So with this, let me welcome you again, and make sure you make good use of this opportunity to talk to our wonderful mentors and guest speakers. Thank you.
Thank you, Emery, for inviting us over. Our offices are just down the street, so it made a quick walk down here. So my name is Tyson Tuttle. I am CEO down at Silicon Labs. I've been there for 20 years, actually. So it's amazing that the company I started as the 10th employee at the company when it was a startup, and now today we have 1,300 employees. And I've been the CEO for 5 years, but I started as a senior design engineer. And actually, if you go back further, in undergrad, my undergrad was at Johns Hopkins, and I'm actually going back and delivering the keynote at the ISCAS conference in May, and that's going to be a lot of fun. I haven't really been back there that much, but when I was an undergrad, I joined the Solid State Circuit Society, and I started getting the red rag in 1986. And I still can't throw them all away. I have it's like 20 feet worth of bookshelf space. Eventually, I'm just going to sign up to the online.
Exactly. Now we are there.
I want to impart some advice to folks. a little bit, but I think the first piece of advice is that this is a wonderful society, and you look at the free flow of ideas and the papers and the people that you meet and the networking, and it also provides a space where the academic folks and the industry folks can get together in a really neutral and independent way. You know, because when we're in business, we're all, you know, it's like, you know, you're designing products and you're doing all this stuff, and this really lets you step back and look at the technology and really share ideas and make us all better. So this is a really, really important organization to get involved in, to read the papers, to network, to go to the conferences, and to contribute and get involved. I mean, in the management of the conferences and the program committees, and there's just lots of opportunity that lets you really get to know people in the industry. And I think that that's one of the first things that's really invaluable. And so this is a great event, and I applaud you guys for doing that. I finished at Hopkins, went to UCLA for undergrad or for grad school. So I dropped out of my PhD, so that's not career advice.
We need that advice as well.
I finished all the classes and then realized that all these guys were smarter. I've got one of them here is Aaron Buchwald, who was at UCLA, and we were at Broadcom together. And he was a guy that I went and always asked the questions to when I didn't know the answer. So I was at UCLA and then came to Austin in 1992. I worked for Crystal Semiconductor. So was right after they had been acquired by Cirrus Logic. So it was a California company, worked on read channels, stayed there for about 4 years. And kind of one of my first pieces of advice is, so I was like hardcore analog, mixed signal design. So some digital, more analog, VCOs and PLLs and filters and amplifiers and all of that. And and also Crystal was one of the first fabless companies, CMOS, mixed signal, maximized digital. And so we worked on a lot of really fun stuff. Did read channels for hard disk drives, ended up doing stuff. This was before Marvell, so we were doing the first PRML read channels in CMOS. And kind of one of the first lessons, I worked, my first boss, his name was Nav Such, and he was one of the founders at Silicon Labs. And he was really a kind of a Renaissance man. He was a good engineer. He'd gone to Stanford, gotten his master's. He went to Michigan undergrad, but Crystal had been in Austin back in the 80s, and I think if they had been in Silicon Valley, they would have broken up and everybody would, but everyone stuck with it, and they worked on really interesting problems. So they worked on chips that were really hard, and it was really, they were picking what to do because it was like the most, they did the first successive approximation, 16-bit data converter in 3-micron CMOS. And they did a lot of the first delta sigma converters, and then they would sell like 10 of them, right? So it's like, it wasn't a great business strategy, but it was really, they developed some really great technology. So first lesson was you better do that in Austin, because if you're in Silicon Valley, you would never have stuck it out. And they did some, and that's the foundation of what Cirrus now, all the iPhone chips and all that stuff now. But Nav had moved into marketing and was doing product definition and all this. And a lot of times when you make mistakes, you learn from those mistakes, or you learn lessons. And so one of the first lessons is pay attention to the business. Understand finance, understand return on investment, understand the market trends and where it's going, understand the competition, and put whatever you're going to innovate into context of what matters. In other words, if you're going to innovate on something that matters and that you can sell and that has a business proposition. If you're going to be in business, if you're going to be in school, then, if you're going to be a professor, then you have a different set of constraints. So that's not my advice. But if you're really going to go into business, understand the market, understand the competitors, understand, the differentiation that you're going to deliver and why you're going to win, and then put a business case. You got to put a business plan. If you're going to start a company, you've got to sit down and do that same discipline. And that's whether you're in a big company, in a small company, a startup, whatever. You've got to figure out ultimately how to design something that people want to buy, and there's a return on that. And so that's point number one. And so Nav had gone into marketing, and so I learned from this. And the first chip I worked on sold, it was $250 million a year. It was a read channel for Western Digital. And it was in every Western Digital hard drive for 2 years, and I worked with, as a an engineer, I was working with the guys on the, at Western Digital, we were writing specs, defining what it was going to do, but you knew that it was a big market. You knew that if you could pull off what was a really hard problem, you were going to have a big success. And so we built a great business. Number two is, if you're going to have a successful business, make sure that you invest appropriately. And if you see the signs, you don't want to just do something and then move on to something else. You have to figure out how to sustain this over time. When you are a startup company, everything is growth. When you are a 20-year-old company, you have things going up and you have things going down, and you have to figure out how to sustain business over the long haul. And so I think another lesson from Crystal was they worked on this product, and then they worked on this product and this product and this product, and they didn't tie together. You didn't get the efficiency of following on things. And then at some point something goes up and then it starts coming down, and you have to have something to replace it with. And so keeping things to where it's like, if you're going to be in the rechannel business, you better realize that you're in a Moore's Law business, and that you probably need a couple teams, and you have to have the right in other words, don't pick a battle you can't win. And so that's another one, is when you're looking at joining a team or joining a project or what you're going to work on, make sure that they have a strategy that's going to win. And because if you're an engineer and you work on something, you can put 5 years of work into something, and it doesn't matter. It's gone. The business is gone. Your time was wasted. I mean, one of my big, as a manager of people, is don't waste people's time. Make sure you get the strategy right. Make sure you get the right talent. Make sure that you understand how you're going to win and then how you're going to sustain that business. And don't waste people's time. Make sure that whatever you work on, you're going to continue to build on that and then evolve it and turn it into something meaningful. I mean, all of us like to go to Best Buy, or see our products in a paper or in a product or selling in the market, and that's something that really matters. I'm going to be a little scattershot here. I've got a few things, and we've got limited time. Another point of advice is, don't get pigeonholed. Don't get a lot of, you go work at Intel and you'll work on that same flip-flop your whole career, right? And I hope nobody's from Intel here. Technology evolves and changes, but even, we encourage folks at Silicon Labs, you'll work on this product for a couple years. Another point of advice is, finish what you start. There's nothing like starting at the beginning of a product, defining it, getting it done, getting it into the market, and seeing it through to production, and then seeing it designed into products and seeing it sold. So this piece of advice doesn't mean work on something and then go jump around too much, but don't be afraid to go from one group to another, or to work on, I was working on this block and now I'm going to work on this block. Don't do that. Maybe do the same thing twice, but feel free to branch out and to try different applications. Maybe you might work on a power circuit, an RF circuit, a data converter, a PLL. You might move from analog to digital. One thing that I did in my career, so I joined Silicon Labs as a senior design engineer. It was a startup. We were working on modem chips for PCs. We basically started the company in 1996, and by the fourth quarter of 1997, we're profitable with 50 people, and we only ever needed $4 million of funding. So it was a pretty successful startup. And we designed a chipset for modems that lets you do the isolation with capacitors. So it was capacitive isolation, transmitting power, clock, and bidirectional signals across this isolation barrier with digital signaling. And they didn't even tell me what they were working on before I joined. So I was at Broadcom. Aaron remembers when I quit. You guys thought I was crazy. And so I show up, and then, I knew that they had some clever circuit or some, and it was like, as soon as they said what it was like, all right, that's straightforward. It's a couple delta sigmas, a PLL, but you could get 2,000 volt isolation. And so I worked on that as a design engineer. The other thing is, think through all the shit that can go wrong, because we were doing great. We were selling chips into U.S. robotics and all this, and the revenue was ramping. And then the summer came, and there were a lot of failures from Florida. And there's a lot of thunderstorms in Florida, and we did all the testing of you spike things and you had all that. Well, if you get like 10 spikes in a row, bad things can happen. So be careful and try to think out of the box as to what can go wrong. But we got through that. But so we did like 3 generations of this chip. It was universally programmable. So it used to be like they had these modems that were cards and PCs that had relays and optocouplers and transformers, and that was how they got the isolation. And you had to have a different card for every country. And so we designed the chip where you could program it to be, like you couldn't sell a UK modem in France and vice versa. Just imagine that, right? And so we made it so you could program the impedance and the line termination and all this. And now you could surface mount the components. It was 2 little CMOS chips, and you could sell it globally. And so that was taking off. The other product that we did in the early days of the company was we did a fully integrated multi-band CMOS frequency synthesizer for cell phones. So this had integrated VCOs, integrated PLL, and multiple PLLs on a chip. And it replaced the PLLs at that time. There were these National Semiconductor. They had all the digital circuits on it, but then the VCO was outside. So you took apart a cell phone, and there were like 200 components, and there were all these modules and all this stuff. And so the first thing was we were going to go design that PLL. And I remember at UCLA, my advisor, Asad Abadi, was working on this stuff. And I told kind of the smartest guy, like there were the smart business guys, and then there was the really smart technical guy, and I kept making fun of him. Like, you're never going to pull this off. It's way too hard. And he really stuck with it. It was like one of these peeling the onion things. It was like you got it back, and it worked perfectly, except the spurs were like 40 dB too high, and we didn't think about how all the digital talked to one another and all the coupling, and we ended up uncovering like a dozen fundamental basically rules of how you design circuits, and we ended up hitting the specs, and we got designed into like 25% of the world's cell phones with this frequency synthesizer. So we were at Samsung and Motorola and a bunch of companies, and I decided that there's smarter people here. So I actually moved over to marketing. So I did 7 years of design engineering and 13 chips, and where from a design manager, design engineer, layout, I did all aspects of that, and just kind of gave it up cold turkey. Not really, but moved over to marketing, and all the engineers were like, "You're moving to the dark side," which is true. So then I would really embrace this, let's go talk to customers, let's figure out what the chip has to do. Back to that first piece of advice is really understand the system and the market, and our goal was to integrate the whole front end of a cell phone at that point. So it was low IF receivers and the whole offset transmit loops for GSM at that point, and then it kind of migrated into 2.5G and 3G. But so we pulled that off. Took us about 3 years, and pulled that off, worked with some just incredibly smart folks doing some of the the fundamental early CMOS work in integrating RF components and doing receivers and transmitters in CMOS. And that was a huge amount of fun. Getting out, working with sales. You knew the market was big. You knew that if you could pull off this integration, it was really transformative. So another lesson from that was we actually ended up having to sell that business in 2007. We kind of realized at some point that we were going to be competing with Qualcomm, and that we were on Moore's Law, and that you had to go 2.5G and 3G and all of that, and that there was more and more software. And so you can get really enamored with a technology or an innovation, but you really have to think system level and think about how all the trends carry this forward with time. I mean, this was a big lesson for us because we thought we were smarter than everybody, and then it was like, wow, there's no way we can compete because we can't afford to make the investments to go after these system companies. And so we ended up selling that business. It was a third of the company. It was $300 million sale in 2007. And we really redoubled back to it being a mixed signal company, but a smaller company. You kind of took a step back, and so that's another lesson, is that you got to think system level and how things evolve over time, and with a longer time horizon than just, if I pull this off, I'm going to capture market, and look at the landscape of the industry and how that can work. And that was a tough lesson, and one that, so it's like when you get into something, you want to have it be sustainable. Back to that original point, that you want to be able to follow on, but it's like you also don't want to get backed into a corner where you're fighting a war you can't win. And so that was a tough lesson. But I think, got to get Daniel up here at some point, who joined the company. You're going to tell all that story, but joined the company as an intern. What, 2002? 2001? In the very bottom. When we went public in 2000, and then we had the cell phone chips that were ramping. So we kind of grew right through the middle of the downturn in 2001, and then again in 2009 we had our TV tuner chips that were coming up and doing quite well. But about 6 years ago, we re-targeted the company around the Internet of Things, and about going after taking basically that cell phone technology and putting it into all the different devices that we have in our lives. A lot of industrial stuff, but now it's half the company. And Daniel's running that group, and is doing a great job. So I'm going to stop talking. You guys can ask us any questions. Totally happy to do that. But there's one other thing that's like a challenge that I had. So I find now that you have to understand technology and you have to understand strategy and all that. But the most impactful class that I ever took in school was a sociology class of how groups work together, group dynamics and understanding psychology and understanding. Because I as a manager now, you can work on hard problems and you can work on the right thing and all that, but eventually you have to work in teams, and everybody's different, and everybody thinks a different way. And I mean, this is in academia, it's in business, it's in whatever, and to be able to relate with people and understand people and motivate people and inspire people, that ability to really think through another person's eyes and embrace the diversity that you end up with as you're working in all these different teams. So if you're still in school, I encourage you to take a finance class and a psychology class in addition to your, and of course as much software as you can get. I'll let Daniel get into that. Yeah. So Daniel, come on up.
Thanks, Tyson. So it's basically great to hear one of us starting as a design engineer and then reach the level to CEO. So this is a big motivation for all of us that somebody can reach that level. So
be careful what you ask for. It's a good job, but it's also a bit of a stressful job.
Exactly. So don't ask for it if you don't want it, but at least there is a path. So even if you're a design engineer, and many semiconductor companies are now getting a business person as a CEO. So for me personally as well, to see that one of us can reach it, and somebody that can talk about technology to us while still running the company in business side, I think it's very precious. And now we have another one of us, so one of the young professionals, and then who is able to reach the level of running a business unit. So I'll ask Daniel to come on.
Good afternoon, everybody. My name is Daniel Cooley. I run the IoT group at Silicon Labs. Tyson's my boss, and he's actually the guy who called me in 2001 and offered me this internship. I was very hungover that day, but I still remember it. He made
You never told me that.
I remember my alternative job that summer was at Barnes & Noble. Right off, I went to my undergrad here at UT, and they used to have this big Barnes & Noble across the street. That was my backup. It was downturn at that time. I'm going straight into it. It was downturn at that time, and getting a job was basically impossible. And I hadn't entered school as an engineer. I had entered school to be a classical musician, actually. And so I was a little behind in the classes for engineering, for EE especially, because I started out from music and went to mechanical engineering and then found my way into EE. And companies that 2 years ago had been coming to school interviewing 30 people for 20 intern spots were coming and interviewing 50 people for 2. I mean, it was basically impossible. So I went through the entire gamut that spring, rejected by everybody. It was horrible. But then this one company decided at the last second to do an intern program that summer, and that's the only reason I was at Silicon Labs. No, I fell in love with it, the company. I didn't realize just how unique it was at the time, but I understand now, having seen a broader scope of the industry for the last few years especially. So today, I'm going to give you guys 3 pieces of practical advice. I'm very big on practical advice. So if you want to write this down, you can. And they're telling me they're videotaping it. If you want to show all your friends this videotape, I still call it videotapes. If you want to show them this, go for it. But I'm going to give you 3 pieces of advice, and I'm going to demonstrate that. I'm going to tell you what they are now, so then you can know when to listen. Number 1, find mentors. Okay? There's some people in this room, I saw them raise their hand, who are mentors. Thank you, mentors. I've had and benefited tremendously in my career from having mentors, but the mentors don't come find you. Number 2, you're going to have multiple careers in your life. Okay, we'll talk about what I mean that. And number 3, you always have to be thinking not about just what you're working on today. Okay, you got to really think a lot about that, and I spent a lot of time thinking about that, but you also have to think ahead in industry trends, and not just your market or your product, what's going on in semiconductors, how does geopolitics affect all of this? I mean, it's all interrelated, and I can see that now, but it took me years of reading and reading and reading to get to that point. So I'm going to go through these things, but I need some water. And if you guys want to stop me, now that you know what I'm going to say, and just ask questions, anybody can raise their hand. I'm here for you, not to hear me speak. So number 1, mentors. My first couple of mentors, I stumbled my way into, actually. I didn't formalize a relationship where I was like, hey, can you be my mentor? And they said, yes, I want to be a mentor, and all of that. And it was just because there was really good people in both the education system. I went to graduate school at Stanford, and Boris Merman and Tom Lee were really good mentors out there, but also at Silicon Labs. So there was a guy named Dave Petrozinski who went to found Blacksand and then went to Qualcomm, and I don't know what he's doing now. And an ex-professor from Romania who named Jan Tesu. And all 4 of these formulated the identity of my engineering mentor-mentee kind of relationship. And I felt free to ask any question, no matter how stupid it was. And I had plenty of stupid questions. But you know, if you seek out these people, especially for the young, I saw a lot of people raise their hand for school. It's only upside for you. And having mentored people now with what I do, it's a lot of benefit from me to do that as well. You don't have to feel bad about finding a mentor. The best mentors actually really like doing it. I've never said no to anybody who's kind of come to me in a formal or informal capacity and asked that. If someone says no, okay, they said no, and you move on to the next person. But find those people, find those relationships, ask technical questions, career advice questions. I want to buy a house, I want to rent, whatever the heck it is. I mean, personal things are okay in this game that we're playing. And another piece of practical thing on mentors, Dave, that mentor, gave me the best paper that I ever read. And it wasn't a technical paper, but it was about engineering. It was called How to Be a Star Engineer. Write that down, How to Be a Star Engineer. You can go get it. It was a formal study that Bell Labs undertook for about 10 years. Back when Bell Labs was the premier technical institution in North America. And they were trying to figure out, they were saying, we hire the best people. They're all 4.0 students. Everybody we hire has to be the best. But then they would look at these people in their career 5 years, 10 years later and realize, okay, now there's a normal distribution. What the heck? Everybody started out, 3 sigma on the bell curve, and they ended up in a normal distribution, as rated by performance reviews and all these other products and papers they would publish and all that. Well, this paper explains how to be a star engineer and how to stay at that 3 sigma level. And it's not intuitive. Not for me, it wasn't, as an engineer. There's a lot of sociology and psychology and the different dynamics from working in a workplace where you have to work in teams versus individual and all of that. So go read How to Be a Star Engineer. That's the first piece of advice. So I started off in chip design. I started off designing blocks for RF transceivers. Actually, Alessandro over here was my first manager. And I had to design a Sigma Delta ADC. And my project was, well, there was already pre-existing Sigma Delta. I thought coming out of school, every design you were ever going to do was brand new from scratch. You know, blank canvas. In reality, that's never the case. Well, very rare is that the case. So he came to me and he said, I designed the Sigma Delta on the last chip and it's awesome. Complex bandpass Sigma Delta, low IF. It was, you know, basically for FM receivers at a 128 kilohertz IF. And he said, except I suck at transistor design, Daniel. You're probably better at that than me. I'm a great system level thinker and the architecture, but I suck at transistors. So I had to take this ADC, shrink it by 50%, reduce the power by 50%, and add a 1-bit switch so that it would shift from a complex bandpass Sigma Delta into a stereo audio left and right ADC with the same circuit. 1 bit, boom, it switches, because we were doing FM receivers and then we were going to start making FM transmitters. And they wanted to reuse the same block. And he said, Daniel, you can only use 1 transistor to do this whole design. And I was just like, what? W over L, I got to pick them and optimize and all this other kind of stuff. He said, 1 transistor, or 1 transistor length. No width. Different lengths. And he's like, when you get to laying out your circuit, you'll understand why. It's because you can lay them out in all the stripes, you know, and then put your poly and wire it up, and it became so easy to do parasitic extraction and all that other kind of stuff. So I started off in core chip level design, and now I'm running a business. And my life is dominated by spreadsheets and PowerPoints and P&Ls and roadmaps and licensing and speaking at events like this. You know, how do you get from point A to point B? And maybe that's the path you want to take, maybe that's not the path you want to take. I certainly didn't know that was the path that I was going to take. You're going to have multiple careers in your career. And you start off doing one thing, you migrate into another, and you should actively seek that out. I agree with Tyson's advice. You don't want to get stale in what you're doing. For me, it was core chip block level design, and then I spent a year and a half in the lab, actually. I designed a bunch of blocks, and then I spent a year and a half in the lab, which some people thought was a step backwards, but for me it was the most valuable year and a half of my career, to be honest. I learned the difference between, you know, transistor level and system level, and, you know, how to write good validation tests, and, you know, how to program. I learned to program in the lab, TCL. We had to create a whole bunch of infrastructure from scratch to make sure that you can ship, you know, 500 million of these things a year if you needed to, and, you know, PPMs matter at that point. So a year and a half in the lab, and then I became design manager in China. I moved from Austin, Texas to China. It was a weird move, but I fought for it and I got it. And then I was leading a team, people that didn't speak my language, in a country I'd never been to. And I'm like, what the hell am I doing? But we figured it out. We taped out a ton of chips. We floated the entire broadcast division for 3 years, Tyson, because you were making automotive tuner hadn't taped out, TV tuner hadn't taped out, and we were just taping out chip after chip after chip. So we were floating that whole division. He was running the division at the time. And I learned a lot managing people that came from very different backgrounds. Most of the engineers grew up during the Cultural Revolution in China. I grew up in a suburb of Dallas. It couldn't be more different. So I had to get very much away from kind of the technical roots. I still had to understand it, but I had to understand the team dynamics even more. Communication challenges across the globe. All of that kind of stuff. It was just like drinking from a fire hose. And then I transitioned from that into marketing. Design manager into marketing. And the reason I did that is because I wanted to define the products. In the Silicon Labs, that meant going into marketing. Not every company. So I went to marketing and I wanted to define products, I wanted to roadmap the products, I wanted to come up with all the scenarios and the platform of all these chips we were going to make, and then make it, present the business case. So I had to learn how to finance 101, and I had to go back to the basics of everything that I knew. I went from being a highly productive design manager, taping out chips that worked on the first time, no metal reps for Apple, for Samsung, for MCUs, for whatever they were, and then I had to go back to how do you write a data sheet, you know, before you have a spec? How do you make a spec? How do you ask the customer what they need? Because they're not going to tell you. Even if they do tell you, they don't really know because they're thinking about their next product and it takes longer to make a chip. So as you move through your career, you're going to have multiple careers. That's okay. Don't be afraid to go back to the basics. A lot of people that I see try to make a switch, whether it's being super productive in one kind of engineering area and then moving over to another, they get frustrated because they don't know the basics anymore. You have to relearn this stuff. You have to keep your mind open while you're relearning it. Don't be afraid to ask questions. Don't be afraid to get mentors. They'll help you. The last thing on this, thinking ahead. That's a really hard thing to do because most of us can barely, or at least when I was doing this stuff, I could barely kind of keep up with where I was. There was, my block had to be finished, it had to be laid out, I had to be validated in the lab. Issues come up with the process or the fab, or just on the transistor side. Product launches and marketing are a different game altogether. But you have to be thinking ahead at all times. And you have to be thinking of what trends are kind of coming together and fusing and driving the industry. Because it was PCs in 1996 when Silicon Labs started, the rise of the internet and the PCs. In the aughts, it was kind of the cellular revolution, and then it was smartphones, and then, what is it now? I know there's a few markets that are kind of driving things. IoT is one of them. We can see that because we're working with these customers. But you have to be thinking ahead, and when I started in chip design, it was like, hey, digitally assisted analog is the thing. Whoever can master the best mix of analog and digital kind of cooperating across this boundary, and who can do the best continuous time to discrete time kind of Z-transform analyses, and all of that stuff is kind of being done. Well, maybe that's now moved into who can make the best software architecture and translate all the way down to hardware design. What transistor level designers can think all the way up stack to tools, okay? And the tools that then you use to write your application, which has a software stack, which has a HAL layer of some kind, which controls some architecture, and that whole stack. And then it extends into the cloud, and extends, where does your product really end? So that whole digital analog idea has shifted into this very complex system where at our company we're hiring cloud developers, gateway developers to write Linux code, C developers to write embedded firmware, transistor level designers to make the chips. So you got to read, and try to understand these trends as much as you can. It's so easy today compared to 15 years ago, 10 years ago. Everybody's publishing on the internet. Twitter's all over the place. If you just kind of look, peek back the curtains a little bit, you can find out what's going on. 15 years ago, you had to go to conferences like this, and you should still go to conferences like this, but that was the only place where you could actually exchange all these ideas. So what I think is kind of ahead for us is embedded connectivity, which is IoT, same thing. AI, machine learning, okay? If you're really thinking big compute and how does software get written, that's one space. And then automotive is another one, kind of the three cornerstone pieces driving the industry right now. And then behind that is all the networking, the data centers, the backhaul, the optical links. So if you're really thinking about your future career in chip design, I'm assuming most people here are, those aren't some bad places to look. You may find more interesting things that are more narrow, and that's totally cool. But these are the things that are growing right now. And you can see that with what NVIDIA is doing in and AMD defining chips for trying to kind of take their GPUs and making them into AI machines. You can see that through M&A, Qualcomm's buying NXP so that they can go an automotive play. NXP bought Freescale so they can get an automotive play. You can see what people are going after out there. And for IoT, there's people, how many Wi-Fi and Bluetooth and Zigbee, and there's all these chipsets that are just flooding the market right now. It's really exciting from a technology perspective. So I'll leave it there. If there's questions, we can go into it. But the three things were find a mentor, and then later be a mentor. That's a big piece of it. You're going to have multiple careers, and I actually think I love that, actually, that you can actually do that in our industry, because you can't do that in all industries. I have friends in finance or energy and gas or pharmaceuticals, and they just do one thing at the desk, and they turn a crank for 25 years and kill me. And then think ahead in your products. What product are you working on now? Where is it going? Where was it 5 years ago? Where is it going to be in 5 years? You may not know. Make a prediction, and think about that stuff. So I'll leave it there. Thank you for your time. I'll be hanging around until about 7, and you guys can chat. So thank you.